Okay, I hope I'm audible to all the students who are attending this lecture of Mathematical Methods for Economics, Part 1. Okay, now in this lecture, we intend to start with a new topic within our course, which is limits and derivatives. It's a fresh topic in Mathematical Methods for Economics course. Okay, whether you have mathematical methods in economics or business mathematics or any mathematical course in your college, okay, you would be coming across this topic called limits and derivatives. So this is a common topic for all the students who are attending the lecture. Okay, so let us first understand the concept of limits. Okay, we will come to derivatives later, but today's class primarily talks about the concept of limits. Okay, today's class primarily talks about the concept of limits. So let's write the definition. I request all students attending the lecture to write the definition of limits. Suppose a function, suppose a function f is defined for all x near a, but not necessarily at x equal to a. Suppose we define a function for all values of x which are close to a, but not necessarily at x equal to a. So I can say then we say that f of x has the number, no annotations guys, I should be the only one to write. F of x has the number a, capital A, as its limit. F of x has the number capital A as its limit, such that limit as small x tends to small a, f of x is tending to capital A. So let me revise the definition with all the students once again. Let us consider a function f. Okay, I suppose students have done the concept of functions in high school. Okay, suppose we have a function f which is defined for all the values of x near a, but not necessarily at x equal to a. We say that the function f of x will have the number capital A as its limit, such that as small as x tends to small a, f of x tends to capital A. So I can write, or we can write it like this: as x tends to small a, f of x tends to capital A. Okay, we can write it like this also, but usually we will be preferring this notation. Let's write a note. Let us write a note. So within note point 1, we say that limit as x tends to a, f of x does not exist if the value of f of x does not tend to any fixed number as x tends to a. So guys, we will simply say that the limit of the function will not exist if f of x does not tend to any fixed number as x tends to a. In particular, if you ask me, so what does this mean? This means that if I say, so if as limit as x tends to a, if my f of x is tending to plus infinity or minus infinity, then we say that limit of the function does not exist, because it's not tending to a fixed number. Initially it was tending to a fixed number, capital A, so we said that the limit exists. But if your function is not tending to a fixed number, it is going to either plus infinity or minus infinity, in that case we say that the limit does not exist. So I hope all students attending the lecture have understood the definition of limits, and you have understood when do we say that the limit does not exist. It will not exist if the limit is tending to plus minus infinity as x tends to a number small a. So now, in case any student has a doubt regarding the definition and the note, only that student should unmute the mic and ask. No other doubts will be entertained except the doubt regarding the definition of limits and the note. Any student who is willing to ask doubts regarding these two, unmute your mic and ask. Okay, then that settles it. Moving forward, I am erasing all this off the whiteboard. In case any student has not written it, don't worry. The process for writing it will be explained to you later. If you have written along with me, very good. If you have not written along with me, please don't worry. We will talk about how you can get access to all this. So now all students will write the heading rules for limits. Also, let me inform all the students who are attending this lecture, it's appropriate for all the economics honor students and the business mathematics students. So all students who are doing economics honors or are having the business maths paper in your colleges, the lectures are completely appropriate for you. Okay, so let's talk about the rules for limits. If limit as x tends to a, f of x is equal to capital A, and limit as x tends to a, g of x is equal to capital B, then rule number 1, limit as x tends to a, f of x plus g of x will be limit as x tends to a, f of x plus limit as x tends to a, g of x, which is nothing but a plus b. So what do we learn? Limit of a sum is the sum of limits. So far I hope it's clear. Second rule, limit as x tends to a. Suppose I take the difference of the two functions. Then again I can separate it and I can write it like this, where we know that the value is nothing but a minus b. So difference of the, so I can say limit of the difference is the difference of the limits. First rule says limit of the sum is the sum of limits. Second rule says limit of the difference is the difference of limits. Third rule, limit as x tends to a, f of x into g of x. These are functions, guys. So limit of a product is the product of limits, which I can write as a into b. Limit of a product is the product of limits. In the fourth equation, limit as x tends to a, if I take the question, so I can write it further as limit as x tends to a f of x upon limit as x tends to a g of x. So limit of a question, or I can say limit of a division of two functions is the division of the limits. So I can write it as a upon b, but provided that your denominator is not equal to 0. Because if the denominator is equal to 0, anything upon 0 gives us infinity, and then my limit will not be defined, because if you can recall, if the limit value is coming out as plus minus infinity, it is not defined. The fifth rule, limit as x tends to a, f of x to the power p by q. Now guys, I can freely take the limit inside the bracket and write it whole to the power p by q. So limit as x tends to a, f of x to the power p by q, I can write limit as x tends to a, f of x whole to the power p by q. The term inside is nothing but a, so a to the power p by q. If a to the power p by q is defined, defined means again it should not be equal to plus minus infinity, it should be constant. And now guys, I can generalize it. I had taken two functions, I can take n functions, I can multiply n functions, I can subtract n functions, okay, I can divide n functions. So what I have done for two functions, I can do it for n such functions. So till here, any student has a doubt regarding the rules for limits, please feel free to unmute your mic and ask. Any doubts? Most welcome to ask.
सर आप एक बार लास्ट वाला समझा दीजिए.
Okay. So what is the last rule telling us? The last rule basically is allowing us to take the limit inside the bracket. So limit as x tends to a, f of x to the power p by q, I can take the limit inside the bracket whole to the power p by q. And limit as x tends to a, f of x is equal to what? It is equal to a. So I can write a to the power p by q. I hope now it's clear. I hope the rule is clear now.
Yes sir. Yes sir.
Yeah. Okay. So now let's move forward, guys, and let's write the sixth property, the sixth rule. So this is the sixth rule. Limit as x tends to a, limit of a constant is the constant itself. So I can write where c is any constant. So limit of a constant is the constant itself. I hope that is clear. Okay. Also, I can write a corollary or I can write a note. Let's write this note. Any doubt to any student? Okay.
सर C 0 भी हो सकता है.
Yeah, it can be 0 also. Yes. Okay. So if guys, if my function f of x is exactly equal to x, then limit as x tends to a, f of x will be limit as x tends to a. What is f of x? X. And limit as x tends to a, x will exactly be equal to a itself. So you can see this is a mirror function, y equal to x. All of us know how the y equal to x line looks like. Y equal to x line or f of x equal to x line passes through the origin. If you want to see the graph of this function, it is like this. It is a 45-degree line. Okay, this is the line y equal to x. So if f of x is equal to x, then limit as x tends to a, f of x is exactly equal to a. Okay, and then let's write another within the notes. This is the first point. Guys, properties are over. Properties were till here. So properties of limits continue. Properties of limits continue.
Hello, sir.
Yeah, ask your doubt, please.
Actually, this is not clear to me. I'm not able to understand.
Which part is particularly not clear to you?
Sir, this note.
Okay, let's talk about the note. The note is telling us, suppose f of x is exactly equal to x. So if I take the limit as x tends to a, limit as x tends to a f of x, what is f of x? X itself. And limit if x is tending to a, x itself will be equal to what? Instead of x, you put a, right? I hope now it's clear. If f of x is exactly...
Yes, sir, got it.
Now it's clear. Okay, good. So let's move forward, guys. The properties of limits, there are 6 properties and they are over. After the properties, we start with the note. So note is different. Note is different from the properties. Within the note, first point you all are convinced with. The second point, if the functions f and g are equal, if the functions f and g are equal for all x close to a, okay, if the functions f and g are equal for all x close to a, then limit as x tends to a f of x is exactly equal to limit as x tends to a g of x. Whenever either limit exists. So let me explain this point to you. Some of you must have understood it by just reading it, but others can properly understand. When will I say that? So when will I say that two limits are equal? Suppose I have two functions, function f and function g. Now, if both the functions are taking equal values for x close to a, that means, guys, in the neighborhood of a, if the functions f and g are taking equal values, I will say that limit as x tends to a f of x is equal to limit as x tends to a g of x. I am again repeating it. Suppose you take a small neighborhood around a. Neighborhood means what? Values closer to a, to the left and to the right. So neighborhood means this. Suppose this is my value a. I take a neighborhood around it. In this neighborhood, if my f and g are taking equal values, it will mean that limit as x tends to a f of x will exactly be equal to limit as x tends to a g of x. That means, guys, if the functions are equal, their limit value will also be equal. If the functions f and g are equal, then at the limit also their values will exactly be equal. So now we can do some practice questions before we move forward. Okay. So
Yes, sir.
any doubt to anyone till now? Okay, then let's move forward and let's practice some questions. So practice questions on evaluating limits. Practice questions on evaluating limits. So guys, within this type 1, evaluating limits, evaluating limits by the process of factorizing, expanding, or rationalizing. I hope all students are familiar with these methods which you have learned in high school. You know how to factorize, you know how to expand using identities, you know how to rationalize. So let's look at some of the practice questions based on type 1. Question 1. Let's look at question 1. Evaluate limit as x tends to 2, x square minus 3x plus 2 upon x cube minus 8. Okay, this is the function which is given to us and we need to evaluate the limit as x tends to 2. Now if we solve this question, what method we can use? We can factorize it further. We can factorize using middle term splitting, using the identities. Okay, so let us see what all we can use. If you look at the numerator is a quadratic function. I can do the middle term splitting. I hope students are familiar with that method. I need to split in such a way so that the sum is -3 and the product is 2. So I can do it like this. -2 and -1 make it -3 and -2 into -1 make it 2 upon, guys, x cube minus 8. You know the identity, a cube minus b cube is a minus b into a square plus b square plus ab. So if I apply this identity here, I can write this as x cube minus 2 cube. This is x minus 2. So x cube minus 2 cube is x minus 2 into x square plus 4 plus AB. AB is 2 into x. So x minus 2 into x square plus 2x plus 4. Now if I further evaluate it, numerator x into x minus 2 minus 1 into x minus 2 on the denominator is written as it is. Okay. If I further evaluate, x minus 2 into x minus 1 upon x square plus 2x plus 4 into x minus 2. Guys, this and this cancel out.
सर 1/12 आंसर आ रहा है.
Very good. Excellent. That's the correct answer. So guys, this is what we get. Do you see why did we factorize? Because if you directly put x equal to 2 in this, denominator becomes 0. So exactly, that is why we had factorized it. Now if you can see, now I can just put in the value 2 minus 1 upon 2 square plus 2 into 2 plus 4. This is 1 upon 12, which is my answer. So I hope all students have understood this question. Any doubt to anyone? Please unmute your mic and ask. Okay, then we can move forward. So clearing this off. Now guys, without looking on to how I am solving, all of you please solve this question. But I will request students to please don't look at the solution on the board. You solve it yourself. I am also solving it. In the end, you can cross check the answer. But no one will say the answer. You can see it on your screen. But solve it yourself. Okay. Let us silently solve it. Ask your doubt.
Sir, after this question, can you please move to question number 1 for 1 second, sir?
I'll have to write it once again. So if you have a doubt, After this class is over, you can personally ask me. I'll schedule a Zoom session for that as well. Okay.
Oh, okay, sir.
Okay. Please unmute your mic. Thank you. Okay. So
Sir, the answer is 3a square.
yeah, very good. But there's no need to tell the answer because ultimately the answer will come on the whiteboard. But yes, you're absolutely correct. Actually, you guys can tell the answer because then you will get the feel as if you are, physically studying from me in front of me. So if that gives you happiness of quickly telling the answer, then you can do that. But there is no gift for anyone who tells the answer first. Okay, there is no gift, unfortunately. If you were studying personally one-to-one in front of me, I would have given you a gift.
So I use the formula of a cube minus b cube. Should I use this one only or should I cut that one?
You can use any method as far as you get your answer as 3a square. In maths, I am completely flexible in my lectures. If you don't want to follow my method, I will actually salute you if you create your own method and get the same answer. So whichever method is fine with you, you can use that, but you should be getting the final answer as 3a square no matter which road you take. Okay.
So what if we would have taken a and x common? Would that work?
You can't take a and x common because it's a plus x ka cube minus a cube. So you
Yes,
can
sir.
either use the a plus b cube identity or the identity which one of the girls was suggesting, a cube minus b cube. But I'll tell you the method which I have used is simpler. If you use a cube minus b cube, even that is fine, but that might involve some more steps. What I have done is I have directly opened it up and solved it. But anyhow, if you're
So
getting
can
the
you
answer, yeah.
please do it from a cube minus b cube just for
I'll not
that
do
I
it
can
in
say.
I'll not do it in class right now because I need to cover up a certain portion, but definitely I can do it in the doubt lectures. Okay. Right now we have to cover
Okay.
a certain number of questions. For that, I will be following the method. You can use that a cube minus b cube method. If you are getting the answer, just WhatsApp it to me. So I'll check your answer and I'll revert to you. Okay, guys.
So
Next
I'm getting
question.
stuck. That's why I was asking, but it's okay.
Just send it to me on WhatsApp. I will check your answer. I'll tell you the mistake you have made.
Sir,
Okay.
I have also done my by this method a cube minus a cube. I got also the answer 3a square.
That's completely fine. If you're getting that answer, whichever method you're using, that doesn't matter. If your answer is coming out correct, then it's completely fine by me. Okay, guys, now let's evaluate this. Okay, can someone tell me the method we will be using?
So
Rationalize.
rationalizing.
Very good, very good, very good, guys. Okay, keep your mics on mute and rationalize this up. So we have rationalized it and then we can continue further. What we have used also, I am writing it. So I will be going at a medium pace. Students who have solved it can gradually wait for the answer to come. So guys, you can see I am using all the steps. Basically in the exam, solve it stepwise because there is step marking in the exam. So please don't miss any step, like properly solve every step. So I guess now students should be getting this answer. So 1 upon root a is the final answer. Now if students are getting that, very good. If you're not getting it, you can unmute your mic and ask. So guys, whenever questions come like these on limits where you have square roots, always rationalize. Whenever you have polynomials, always either factorize or expand. Now what to do? You will get this with practice. These things only come with practice. The more questions you will practice, you will get an idea. So after practicing like more than 60-70 questions, you will just look at the question and you will tell that, okay, we need to do this. But you need to practice questions. Now I will be providing you with various online books and assignments for practice. It is your job to practice, and I will be giving you solutions also for the same. Okay, now the last thing we do for the day, after which we stop. Okay, so all students will write the heading type 2. So guys, type 1, if you remember, finding out limits by expanding, by rationalizing, okay, by factorizing. Type 2 are limits involving infinity. Limits involving infinity. Now, how do we solve limits which involve infinity? So to understand this, first of all of you should know the rules of infinity. All of you should be familiar with the rules of infinity. So write them. Infinity plus infinity is equal to infinity. Second rule, k into infinity, where k is a constant, it will be equal to infinity if k is greater than 0 and minus infinity if k is less than 0. Third rule, infinity upon k will be equal to infinity if k is greater than 0 minus infinity if k is less than 0. Okay, where k is a constant. Fourth rule, infinity to the power k will be equal to infinity if k is positive minus infinity if k, not minus infinity guys, 0. Let me correct myself, 0 if k is negative. Infinity to the power k will be equal to infinity if k is positive and 0 if k is negative. Then let's write the fifth rule, on the right hand side. You can see infinity into infinity is also equal to infinity. Okay, the sixth rule, e to the power infinity, where e is a natural exponential function, e to the power infinity is equal to infinity. E to the power minus infinity is 0. And then we have the seventh rule, the eighth rule, which is 0 upon infinity is 0. 0 upon infinity is 0. So I hope so far it's clear to all the students, the rules of infinity. And guys, then we write some indeterminate forms. We don't know these values. So write indeterminate forms. Indeterminate forms means We do not know their value. So we don't know the value of infinity minus infinity. You can think that research is still going on these. We don't know the value of 0 to the power 0. We don't know the value of 1 to the power infinity. We don't know the value of infinity by infinity. We don't know the value of 0 by 0. We don't know the value of 0 into infinity, and we don't know the value of infinity by 0. We don't know these values. So you all should be familiar. So suppose in the question you get one of these, you cannot calculate the limits because these are indeterminate forms. You cannot evaluate their limits. So guys, this is where I intend to stop in this lecture. Okay, I have kept a short lecture today because the objective was that it's a new topic and I should keep a small lecture to introduce the new topic to you. From the coming Thursday onwards, when we are primarily into limits, the classes will become for more than 1 hour. Okay, so I hope all students have enjoyed the lecture.
So you also teach integration?
Yeah, I do teach integration as well. Now guys, please look on to what I'm speaking. If you have any doubt regarding limits, we are done till now. You can unmute your mic. You can call me. You can mail me your doubts at divineschooloфeconomics@gmail.com. So you can mail your query to me at divineschooloфeconomics@gmail.com. And now I request all students attending this meeting to leave this meeting and join back again using the same link. I request all students to leave this meeting and join back again using the link for single variable differentiation, which is the same link. Okay.